It is another lovely and wonderful moment on Mathematics and Science Meal. Welcome to Mathematics and Science Meal. Today we are considering mathematics, so that's why we have Mathematics Meal. And the topic we want to consider is fractional indices. Subscribe to our YouTube channel at Mathematics Meal 1 and follow us on Facebook at Mathematics and Science Meal. Alright, without taking much time, let's begin today's business on Mathematics Meal, precisely on the topic fractional indices. Now we know that the index of a number shows us the number of times the base will multiply itself. So if I have 5 to the power of 3 means 5 times 5 times 5. 5 to the power of 3 means multiplying 5 into 3 times. 5 times 5 times 5. So this is the power or the index. It's showing us how many times 5 will multiply itself. So if I have 2 raised to the power 4, it is 2 times 2 times 2 times 2. This is showing us how many times 2 will multiply itself. But supposing I now have 8 raised to the power 2 over 3. How am I going to handle this? How will I multiply 8 into 2 over 3 times? That's the issue now. Okay, so how do we handle this? Very simple. That's the concept of what? Fractional indices. So I can say that fractional indices result when the powers of terms are fractions. So when the powers of terms are fractions, we are going to have what? Fractional indices. So anytime the power of a term is a fraction, then we can talk about the fractional indices. So examples of such terms include 4 raised to the power 1 over 2. The power here is a fraction. Then another example, we can have 9 raised to the power 1 over 2. We can have 8 raised to the power 2 over 3 that I've used here. It's still possible that the power will be negative, so I can have 27 raised to the power minus 1 over 3. It's still possible that the fraction, the base will be in decimal, so I can have 0.125 raised to the power 2 over 3. It's still possible that the base will be a fraction that carries a fractional power, so I can have something like 16 over 9 all raised to the power 3 over 2, and so on. So you notice one thing is common to all of them. The powers are what? Are fractions. So whenever we have terms with fractional powers, then the terms are said to be fractional what? Fractional indices. Fractional indices. So generally we represent fractional indices as shown below. So we have a raised to the power m over n. A raised to the power m over n. That is when the base is an integer. Then, if the base is a fraction, we're going to have a over b raised to the power m over n. So you see, this is the power, which is a fraction. This is the power, which is a fraction. So the question is this: how do we handle fractional indices? When we have fractional indices, how do we handle fractional indices? So that's the issue. That's the main issue. At least now we can actually identify fractional indices. We say they must have fractional powers. So all these here are fractional indices because the powers are what? Fraction. If I have something like 2 over 5 raised to the power 2, this is not a fractional indices, even though the base is a fraction, but it's not a fractional indices. What makes it fractional indices is on the power. The power here is a whole number, so it's not a fraction. Since it's not a fraction, this is not what? Fractional what? Fractional indices. Okay. So how do we simplify fractional indices? So simplification of fractional indices. How do we simplify that? Very important. So simplification of fractional indices. To simplify fractional indices, we take these steps. Step number 1, take note of the term or expression use appropriate rule or law to remove negative sign on the power if there is any. Okay. Write the term expression in root power form. This is the cutting root power form. We are going to see what we mean by root power form. Write the expression in root power form. Why? Why should we do that? So, in fractional indices, the numerator of the fraction is taken as the power, while the denominator is taken as the root. So write it in root power form. Write it in root power form, following this principle. After doing that, the next thing is evaluate the root, then the power to obtain your answer. Or evaluate the power, then the root to obtain your answer. Okay, so these 4 steps will help us to solve problems on fractional indices. But there are rules that we need to put down in order to use these particular steps, these steps that we have listed here. So take note of the term or expression. Use appropriate rule or law to remove what? Negative sign on the power if there is any. If there is any negative sign. If there is none, we'll just skip this step number 2. Then write the term in root power form. In fractional indices, trying to explain what we mean by the root power form. In fractional indices, the numerator of the fraction is taken as the power, while the denominator is taken as the root. Then after that, evaluate the root, then followed by the power to obtain your answer. Or you can still decide to evaluate the power first before evaluating the what? Evaluating the root. Okay. Now, there are basic rules in fractional indices. Let's list those rules. Basic rules in fractional indices. What are these basic rules? So, basic rules in fractional indices. Fractional indices. What are these basic rules? Rule number 1, a raised to the power m over n is the same thing as n root a raised to the power n. That's what we mean by the root power form. So we have a raised to the power m over n. This is the numerator of the fraction. It becomes power. The denominator becomes the root. You see that? So this is the power, this is the root. So m is the power, this is the root. So writing it in root power form, in root and power form, that's what we mean. So whenever we have fractional indices in this form, it should be taken in this to this form, and then we evaluate the root, then the power, before we can obtain our answer. That means a fractional indices in this form can also be written like this. So if I have these fractional indices in this form, I can move it to this. If this can go to this, it means that this can also become this. Very important. It means that this can also become this. So if this can become this, then this can also become this. Okay? So now if there is a negative sign, let's say I have rule number 2 now. I have a raised to power negative m over n, a raised to power minus m over n. The first thing is to remove the negative sign. So I have 1 over a raised to power m over n, and this can now be 1 divided by n root over a raised to power m, because of the negative sign. You remember the fourth law of indices, where we say that the negative index is something as the reciprocal. Yeah, you still remember this in basic indices. So we have the third rule dealing with when we have fractional base. So this is m raised to power n. What do we do? Still the same principle. N root of a over b, all raised to power what? M. That's what it means. So the fourth one is when the fractional power has negative sign. So if I have a over b raised to power minus m over n. So what we do is to turn the fraction upside down. Remember, not the power but the base. So this will become b over a, all raised to power m over n, just to remove this negative sign. And then we move further to say n root over of b over what? A raised to power what? M. Okay, so these 4 rules are very important in handling what? In handling fractional what? Indices. Just make a copy of these rules, very important. When we return in the next part of this, our business will be to solve some problems. So that's why you need to make a copy of these rules, and then note this also. Although I'm not going to clean this, this will still be here when we are going to start solving problems on fractional indices. Don't go too far, because we'll just return in a moment to continue with our business on fractional indices. And in the next part, our business will be to solve problems and problems and problems on fractional indices. Remember, I'm still your lovely friend and tutor, Engineer Ike. Okay, I love you.